All right, moving on today to 3.2. Today we're going to be graphing linear inequalities. All right. Yesterday we just graphing inequalities, which are on a number line. Well, now we're going to have an x and a y-axis, not just a single axis. Couple things to keep in mind. The difference between inequalities. If there's no bar, we are going to have a dash line. If we have a bar equal sign, we will have a solid line. The other things to keep in mind is the shading. If we have a greater than symbol, we will shade above the line. Either it's greater than or equal to, we'll shade above. A less than or equal to side, we will shade below that line. All right. We're going to graph today primarily in slope-intercept form with our first example. If you can right now, I'd like you to pause your video and get this into y equals mx plus b form. All right, so as I do this, I'm going to get the y by itself as my final goal. I'm going to subtract 4x from both sides. Once again, y by itself. Boom. Now, as I go to solve these, if I ever divide by a negative, I'm going to have to flip my inequality, so keep that in mind. Right now I'm at negative 3y is less than negative 4x plus 6. All right. Now to get the y by itself, I have to divide by negative 3 everywhere. So as I do this, the negative 3's cancel, I get y, but because I divided by a negative, I'm going to flip the sign. It's going to become a greater than symbol. I'll now get 4 over 3x, and now positive by a negative is a negative. So now we have our x and y axes right here. Here. And we'll start the actual graph of the line. All right, once again, y-intercept is right here. So we're going to start down 2 units. And then from there, we're going to go right 3 and up 4. So right 3, up 4. And then I'm going to repeat, right 3, up 4, right 3, up 4, puts us through here. Oh, I want to hold off on that. All right. Now, we talked about earlier the differences. Once again, no bar means the line is dashed. So as we go through, go like that. And we're going to come down here, and we'll go all the way through. Now, what that is saying is, by having a dashed line, that any point on the line is not part of the solution. So this point here at 6, 6 is not a solution. If I plug those values in for x and y, it'll make the statement false. All right, now it comes to the shading. And what I do is I go to the y-intercept, and then I decide if I'm shading above or below. Because it's a greater than symbol, that means I'm going to shade above it. Greater than is above. So I'm going to take my pen or pencil, I'm going to shade everything over here. So what this tells you is any point that lies in the shaded region, any xy coordinates, so negative 5, 5, this point, if I plug them in for x and y, they'll make this statement less than 6. Any point over here, say 7, 0, if I plug it in for x or y, x and y I should say, it will not be true statement, it'll be false. All right, we'll come back with another example like this, and then we'll get in some horizontal and vertical lines.